Earlier we saw communication involves three entities. One, sender. The second one, receiver. And then the network in between. Now, if the sender and receiver are in same network, what does that mean network? 10.0.0.1, 10.0.0.2. See, both starts with 10. When sender and receiver are in same network, we call it as LAN communication. LAN, local area network communication. LAN communication. What type of network it is? It's LAN network. You may have more than one device in a LAN. Right now we have two devices. You may have more than one receiver, or you may have more than two devices in a LAN. But to connect more than two devices, we need some device in the middle so that we can connect it to more devices, so that this four devices can communicate each other. So what they did is, initially they came up with a device called amplifier. Amplifier is a device in the olden days. The purpose of this device is to amplify the signal. Signal needs amplification. Why? If this cable is very long, let's say this PC and this PC is 100 meters away. Assume it's 100 meters away. 100 meter is really a long distance. So you need an amplification device. We need a booster. We need a device that will boost up the signal. And it is called as amplifier. For example, the signal that is sent from here, the data that is sent from here, as it travels, it becomes weaker. And it cannot reach the destination. It cannot reach the receiver. So when you keep amplifier, it again boosts the signal so that the receiver can receive it. Signal is getting boosted so that it can travel long distance, so that it can support long distance communication. Amplifier boosts the signal, amplifies the signal. But there is a drawback in this amplifier. What? In the path, if there is some error attached, we call it as noise. Along with the data, some unwanted bits gets created. We call it as noise in the network. Noise. What is noise? Unwanted sound. Correct? That is noise. If someone is singing so beautifully, you will not call it as noise. Why? It is so beautiful, you like to hear it. You don't call it as noise. If a dog is barking continuously, you call it as noise because you don't like to listen to that barking sound. Likewise, this green one is not the data that you want to receive it. Green one is not the data that is sent by the sender. It gets added in the path. To your data, this junk values gets added. How is it added? How can a junk value added? The electromagnetic force, which is already there in the earth, it will generate some electrical kind of electrical impact on the wire. So the wire which is carrying data now gets new electrical impact, like bits and bytes getting added. We call it as noise. So the problem with the amplifier is it will amplify everything that comes in. So along with the data, even the noise gets amplified. So if you send a high, here you may receive like A @ H $I, something like that. But what you send is just high. But what you are receiving is something else. Your H is there, I is there, but these are all junk values, noise, unwanted data, noise. Noise get attached, noise get added to this data. So the receiving router not only receives the data, it also receives noise. Right. To avoid this, see, when we send high, we should receive only high. We cannot get this garbage value. So to avoid this, they invented a device which can filter the noise, and it is called as a repeater. The job of repeater is only to regenerate the data. Repeater can easily identify the noise. See, the noise is getting injected into repeater, but when it comes out, no noise. It only regenerates the data. Only the data is regenerated, not the noise. So the receiver now receives only high. High is sent, high is received. So far we have seen two LAN devices. One is amplifier, the other one is a repeater. We do have repeaters today. We have it. We do have repeaters today. On the roadside, you can see something like this. Black color hanging. One wire will be going like this. Network cable. On the main road, you can see on the side a black color cylinder. That's a repeater. To boost up the signal, they keep it. In the city of Bangalore, you can see that on the roadside, hanging here and there. Fine. So, a repeater has got two ports. So you can only connect two devices, A and B. If I want to have more LAN device, (10.0.0.1), 10.0.0.2, the repeater cannot support me. Why? Repeater will have only two ports. But in order to connect this 4 device, I need more port. We call it as hub. Hub is a multi-port repeater. Hub is a multi-port it's a multi-port repeater. A repeater with more ports. Hub is a multi-port repeater. So what hub does? It regenerates, it boosts. See, hub is not only to connect four devices. If a signal is coming weaker, it can boost the signal and send you data with very strong signal. So don't think hub is only to connect multiple devices. No. Hub is a multi-port repeater. It can regenerate the signal. You know how hub can do it? There will be an electric power connected to your wall outlet. That electric signal will go and boost up the data signal that is coming in. So hub can regenerate, boost up the signal. But if you see any hub without this electric connection, then they cannot boost up the signal because they don't have the power. They can simply allow you to communicate between these devices, that's all. So there are some hub which will not boost up the signal, which will be used as the junction box. That type of hub is also available in the market. But what we are learning is a hub which can allow you to connect multiple devices at the same time, which can also boost up the signal. Boosting of the signal. But there is a drawback with hub. What is the drawback? Hub has got a logical bus topology inside. What is bus topology? You will have one common backbone to which many devices will be connected. Actually this is 10.0.0. Alright, just write 10.0.0 here. Now if 10.0.0.1 wants to communicate to 10.0.0.3, a packet will be generated with the source address 10.0.0.1 and the destination address 10.0.0.3. When this packet hits the port, the common backbone, it will take a copy of this and give it to everyone. What do you understand from this? Hub always broadcast. Why? Because it has got one broadcast domain. It has got only one path to reach everyone. Only one broadcast domain, only one path. We call it as broadcast domain, only one path which is responsible for controlling the broadcast between these devices. Hub has got only one broadcast domain. There is also a word called collusion. Hub has got only one collusion domain. What is collusion? What is collusion in Telugu? Emandi. Collusion ante emi. In Tamil, what is collusion?
So sending.
Kiran garu, collusion ante emi. You don't know? I think you are in mute. Unmute and talk if you are talking. I cannot hear you. See, if two people are fighting, that is also called as collusion. If two buses dashing each other, hitting, accident, we call this collusion. If you are going to market, full rush, what you have is more collusion. Everyone will hit on every other people. I remember once in Chennai, in a place called T Nagar, full collusion that road. You might have seen such thing in many places. Collusion means too much population, too much people in the road. That will cause collusion. Accidents, dashing each other. You see, there is only one backbone to carry all the data coming from 1, 2, 3, 4, 5 computers. If all 5 is sending the packet, it will go to all other 4 devices, which will consume this bandwidth. Bandwidth will be fully consumed, occupied. And the packet will collide each other. Dishum. That is what collusion. To control the collusion, do you have any mechanism? Nothing. This is the only backbone. So you need to send less amount of traffic on this one backbone to avoid collusion. So this is one link that is responsible for controlling broadcast as well as the collusion. Hub will always broadcast, because there is only one path to speak to everyone. See, if you will have a separate path to reach this computer, this computer, and this computer, then you have separate collusion domain. To avoid collusion, you have separate route. But hub don't have such a option. Hub has got only one common backbone. Again, it's not a physical bus topology, it's a logical. Similar to this, logically, you will find inside the hub. Similar to that, a logical architecture will be seen inside the hub, motherboard. So, this is the drawback of hub. See, if there is only one road for the Prime Minister, for the President, for the citizens, there will be always problem. Why? When Prime Minister want to go, he will block the road, and others have to suffer. If you have only one road for fire service, for ambulance, for the citizen, problem. Collusion. Have you seen? You have definitely seen in India. Evening time you see, ambulance cannot go freely. Fire service, if there is any fire, the fire engine cannot go fast. Because full of collusion. Everyone is using the same road. Only one road. Very difficult to manage. So what we need to do is, we need to send ambulance in a dedicated road. So in Bangalore what they have done is, okay, fine, how to control this collusion? They put a separate lane for all the Bangalore buses, BBMP or whatever, BMTC buses. They have a separate track. Inside that track only bus should go, because bus is going here and there and creating too much of nuisance, collusion. This car and bike is getting trouble because of the bus. If road is only this much size, one bus they stop here, one bus they stop here, then how other cars will go? So they found one solution in Bangalore. What? Buses should not go here. Buses can go only inside this lane. So car and bike and all the vehicles will go and use this 80% of the road. 20% is for the buses. That avoids collusion, no? Putting separate road avoids collusion. See, small country like Oman does something better. Very less population, very less tax. They do something better than what this Bangalore has done. What they do, you know? Helicopters. You call an ambulance, helicopter will come to your house in Oman. And they will pick you up in the helicopter and they take you. Every time you see helicopter flying, ambulance, fire service, all flying on the top, not on the road. That is government. Fine. Now let us not get into that. Bus topology means always there is broadcast. If you add more device, more collusion here, then no one can use the backbone. Everyone comes and blocks the road. What will happen? No traffic will move. You have seen, no, in the main road. Many times I have seen. No one can go. No one can go in the road. So opposite guy comes this way. This guy goes this way. And there is one bus here, there is one bus here. No one can go now. He wants him to give way. This fellow wants him to give way. No one is going to give way. Struck. So everyone is standing behind. Finish. Traffic jam. Boom. So if you have only one road, that is the problem. That is why what they did, they put a splitter for going this way, for coming this way. That prevents a lot of problem actually. That avoids a lot of collusion, which you don't have in hub. In hub, you got only one broadcast domain, one collusion domain. With that one road only you have to avoid collusion. If you want to go anywhere, you have to go only via that one road, one broadcast domain. Broadcast means what? Going to everywhere, anywhere. You can go anywhere. Anything that is sent to that backbone will go to everyone. Due to this reason, because you got only one backbone, hub supports only 8 ports. This was once upon a time CCNA question. I don't know whether it is still asked. Wait, let us Google. The reason why 8 is you have only one backbone. If you keep adding more device, more broadcast and more collision, it cannot be controlled. That is why 8. Three, 6, 7, 8. You cannot have more than this because the backbone cannot manage. So they came up with another device called switch. Switch will also have one broadcast domain, like a hub. Meaning, same like this bus topology, you will have one. Not only that, it will also have a star topology. What is star topology? This is what called a star topology. Let's say we have A device connected here, B device connected here. No, I will draw inside this box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is switch. It can have more ports. And you are connected to a device called A, B, C, D, likewise. If A is talking to C, the source address of the packet is A, the destination address of the packet is C. When this packet approaches the port, let's say this port number is 1, 2, 3, 5, 6. Goes on. Now what this port will do, it will listen to the frame and it will learn the MAC address of the incoming frame. So what it does is it maintains a MAC table in which it will learn like source called A connected on port number 1. It learns. This is not seen in the hub. Hub don't learn anything, but switch learns. Switch learns. So it learns the MAC address of the connected device. See, A is connected on port number 1. Switch has learned it. How? When a packet comes from the source address, it learns. Now where it wants to go? To the destination C. But there is no information about the destination C. So what it will do? It will use this common backbone so that it will go to everyone. So when it comes to B, B ignores it. When it comes to C, C will answer. All other device will ignore and C will respond. When C responds, what will be the source address? C is responding, so source will be C. What will be the destination address? It is responding to whom? A. Now when this packet approaches this port, again switch listens. It learns from the source address that on port number 3 there is someone called C connected. It learns the MAC address of the connected device. So it knows the location of every device. It knows who connected on which port. After a point of time, they keep communicating. Then port number 2, B MAC address. Port number 4, D MAC address. It learns all the MAC address of connected device. Say for example, when this is response packet, C wants to go to A. When the packet hits B, it learns the source MAC address and then it will check for the destination, where I want to send the packet. Where should I send the packet? I need to send the packet to A. A is on port number 1. So what it will do, it will directly send it to 1, meaning instead of using this backbone, it will use this dedicated path. A wants to send to C, so it will send directly to C. Because it knows the C's location. It uses star topology. It can directly send it to port number 3. It won't use the backbone. Only when the destination is unknown, it will use the backbone. So question to you is, will switch broadcast always? No. But hub will always broadcast because it never learns the MAC address. Hub always broadcast, but switch only if the destination is unknown. If the destination is unknown, it will broadcast. Once the destination is known, it will not broadcast. Fine. What is next? We have learned about switch behavior. Switch learns MAC address from the incoming frame's source address. Switch knows the destination by learning the MAC address. As a result, it need not to flood always. It need not to broadcast always. Broadcast is done only if the destination is not known. Broadcast is done only if the destination is unknown. Yeah. So switch, because it can avoid collision. How you can avoid collision? By taking a separate path. If you learn the MAC address, you can go directly to D. If you want to go to D, you can go directly from here to port number 4. That avoids collision. If you use this common backbone, always collision. You avoid collision. Because you avoid collision, switches are not too busy. Switches can handle more traffics. But hub cannot handle more traffic because they don't know how to avoid collision. So only 8 ports, only 8 devices you can have. If you have more than that, hub cannot control. But switches, every port can make their own path to destinations when they know the MAC address of the destination and their location. As a result, there is a separate collision domain on each port. Meaning, switches have got one broadcast domain, but the collision domain is not one. If I have 24 port switch, you will have 24 collision domain. Kiran, you tell me, if I have 96 port switch, Kiran should answer this. If I have 96 port switch, how many collision domain I'll have, how many broadcast domain I'll have?
Broadcast domain.
Sorry, how many?
One broadcast domain
Mm-hmm.
and 24 collisions.
I have 96 port switch. If I have 96 port switch, how many collision domain I'll have?
96.
Very nice. So every port on the switch will have a collision domain. See, switches are too big size. You also have 100 port switch, 300 port switch. They can handle more traffic because they have a separate collision domain, a dedicated path to reach the destination. Fine. So what we have learned as a difference between hub and the switches, hub always broadcasts. Hub always broadcast. Switch will broadcast only when destination is unknown. Only when destination is unknown. Hub never learns MAC address. Switch learns from the source address of the incoming frame. Hub will have only one broadcast domain and collision domain, whereas bridge means switch will have one collision domain, so one broadcast domain and n number of collision domain, where n stands for number of ports. Now all these devices that we have learned so far, they are called as LAN device. There is also one more called NIC, network interface card, which is there in your computer. That is also a LAN device. NIC, amplifier, repeater, hub, switch. All these devices are local area network device. Why? If you have a computer with 10.0.0.1, 10.0.0.2, you can use switch or a hub to help them communicate. It's a LAN device. When you have 20 network, 30 network, none of this device will support. Because communication between different network will come under WAN, not LAN. See, some people will tell like this: LAN means network within a building. That is wrong. See, this is also in the same room. I have one computer in 10 network, another computer in 20 network, another computer in 30 network. Nowadays within a company we will have many subnets. So what you need here is you need a WAN device. What is WAN device? Router. Router helps to communicate between different network. This is how we draw a router. Router is a wide area network device. Switch, hub, repeater, amplifier, NIC card, all are LAN device. Now we have a switch called, in Cisco we have a switch called multi-layer switch. This basically it's a LAN device, but you can enable routing in it. Then it will become WAN device. That is why it is called as multi-layer. LAN is layer 2 in OSI. WAN is layer 3 in OSI. WAN means what? IP network. Different networks. We call it as multi-layer switch. But generally switch means it's a layer 2 device, LAN. What about the hub? It's a layer 1 device. Repeater, layer 1 device. Amplifier, layer 1 device. NIC card, layer 2 device. Listen. If your device can learn MAC address, then it is layer 2. In OSI reference model, layer 2 is the place where MAC addresses are seen. Data link layer. Does switch learn MAC address? Yes. So switch is a LAN device. Does hub learn MAC address? No. So hub is a layer 1 device. Even though it's a LAN device, it is layer 1 device because it don't learn MAC address. Amplifier, repeater, they don't learn MAC address. So we have understood here the difference between LAN and a WAN. Local area network is the device that are in same network. It's not in same building. Even in same building you may have WAN. Connecting to more than one network, you need a router. Connecting to multiple networks, you need a router. Connection within a network, you need only a LAN switch. Routing between networks, you need a WAN, you need a router. So, we have learned LAN device and WAN device. Now one more I want to explain you, this may be asked in interview. There is a LAN device called bridge. See, I have not listed that bridge here. I said LAN device, NIC card, amplifier, repeater, hub, switch. But I did not write repeater because repeater and switch are not different. It's the same. Only the difference is this. This is how the question will be asked. What is the difference between bridge and a switch? See, both are going to learn MAC address, both learn the MAC table, both are layer 2 device. Those are all similarities. They will not ask you similarity, they will ask you what is the difference. See, if it has got two names, there should be some difference, no? Auto. You have auto, no? In India, auto rickshaw, auto. You cannot say all autos are same. In Bangalore, if you see a green color auto and a blue color auto, it is different. Green color auto is a public service. You can hire it. Blue color is a private auto. Both takes people inside, but the green one will take passengers, blue one will take the owners. Likewise, both are looking same auto, but the license plate is different. Green color auto will have white color board because it's a public service. Blue color auto will have, sorry, I'm saying opposite. Green color auto will have yellow color boards, a public service. Permit, public permit. Blue will have white and black, like our bike. Private autos. Likewise, both the bridge and switch are layer 2 device. They learn MAC address from the incoming frame source address. They learn MAC address and they form a separate collision domain. All these things are fine. But when someone asks you what is the difference between bridge and a switch, there is definitely a point to say. Bridge is a software based device. Switch is the hardware based device. They are not the same. When you hear me saying this, what things come in your mind? When I say bridge is a software based device and switch is a hardware based device, what comes in your mind? Speak out, please, anyone.
Hardware means it's physical device. Software means any software installed, then only we can use.
What, Kiran, what do you think about this? Bridge is a software based device, switch is a hardware based device. What answer you will give? If I ask me what is the difference between bridge and a switch, you are telling me bridge is a software based device and switch is a hardware based device. So now I am asking Anandam, what does that really means? Kiran is saying bridge is a software based device and switch is a hardware based device. What it really means? So what will be our answer, Anandam? What will you answer for this? If I ask you more explanation, what it really means, software based device?
Based on software.
Okay. Kiran, what is your answer? Both are hardware. I will show you it. Both bridge and switch are hardware. Then why they say software based device? I'll give you an example. In olden days, we had watch, HMT watch. What is the difference between the HMT watch of the olden days HMT watch and fast track watch of today? Tell me. Both are watch. Similarity is both show the time. Like both bridge and switch learn MAC address. Both bridge and switch are layer 2 device. HMT watch and fast track watch both show the time. What is the difference? HMT watch will not have a motherboard. Fast track will have a motherboard. In HMT watch, you will see inside lot of pulley. You know pulley? Round. Pulleys. And you tighten the key and there will be one spring kind of thing that makes the watch to work. Whereas in fast track, you will not have any key. You will have only battery. This is software based device. This is hardware based device. Both are watch. But this is full of hardware that controls and provides you the timing. What is giving you time? It's not a software that shows you time. The hardware, the pulley, the spring. Here the same needle shows tick, 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 but controlled by batteries and motherboard. Both are same, but not same. One is software based device, one is hardware based device. Exactly the same thing here. Bridge is a software based device. Every function is carried out by one single processor and the operating system inside this box. Whereas here, you have a processor, you have operating system, also you have many lot of hardwares, additional hardwares that will be used for listening, forwarding, decision making. We call it as ASIC chip. This hardware makes this switch more faster, better than only one processor taking all the load. Here only one processor need to do everything. So bridges cannot be too big. You cannot have too many ports. Switches you have too many ports because you have lot of hardwares sharing the load in controlling the packet forwarding. So switch is a hardware based device because it has got ASIC chip, which is taking the load of the processor on it, sharing the load. Whereas bridge is a software based device. The entire load of the switch goes on one, entire load of the bridge goes on one single processor. So it cannot handle too much traffic. So if someone asks you this question, what is the difference between bridge and a switch? Your answer need to be, bridge is a software based device, switch is a hardware based device. Mostly he will say okay, and he will go to the next question because he don't know the real meaning of it. But sometime if he is curious to learn from you, he will ask you the question, what do you really mean by software based device, hardware based? Then you can tell him, software based device has got only one processor and the operating system to do all operations. Whereas hardware based device, along with the operating system and the processor, it has got more number of ASIC chip, which shares the load. In turn, switches can handle more traffic than bridge.